Just wanted to say before I begin, a big thank you to Nearform and Intercom, and of course to Sean and Leanne for helping organise this. So the talk tonight is saving lives with Node.js and the air ambulance service. So just quick introductions and that. Who am I? My name is Nigel Hanlon, and I'm a senior software developer at OpenApp, who are just over on Parnell Street there. They do a lot of work with healthcare, health registries, and one of the areas that they work in is making data useful. So, for example, data visualization, interpretation, that sort of thing, but primarily with open source technologies. So my part is I work primarily on GIS. So GIS is Geographic Information Systems, which essentially means they develop maps to solve problems. Whether those problems are population analysis, whether they're identifying service black spots, routing distances between points. It's a vast subject, and hopefully tonight through this talk I can show you just one aspect of what we do, which is develop software for the air ambulance service. So tonight, just talk outline, I'm going to go through the air ambulance service itself. So essentially from calling 999 to how someone gets as far as the hospital door. I'll be covering the Health Atlas Aeromedical System, which is the GIS system we developed to help get patients to hospital through the air ambulance. I'll also be doing a live demonstration of that, so you know how live demos go. Hopefully it works. So I'm going to just, after I show you the application, I'm going to go into just a little bit about the web mapping and the GIS technology behind it. The ESB power lines that we have in the system, there's close to 1 million of them there, between high voltage and medium voltage and low voltage and so on, which presented a great technical challenge, which I'll talk about later. I'll also go into real-time aircraft tracking that we do. We track the Air Corps helicopter and the various Coast Guard helicopters as well. So there's a bit in that, especially the Coast Guard, which is a rather unique case there. The Locate Me 112 system, which allows patients to be found using geolocation on their smartphones. Hopefully I'll demo that as well, and hopefully it'll work. And then just a few future developments, what we're thinking in terms of newer versions, and questions and answers at the end, of course. Right, so here goes nothing anyway. So the air ambulance service from 999 to hospital door. So by a show of hands, how many people have ever actually had to call 999 or 112? Okay, so a few there. So when you call that number, you're put through to ECAS, which is the Emergency Call Answering Service. They're the ones who ask you, what service do you require? Whether you require the guards, the fire service, or in our case, the ambulance service. So ambulance requests are handled by the National Emergency Operations Centre. So it's a dedicated call centre for any medical sort of emergency. So they're the people who will talk you through if there was an accident, what you should do, things like that. There's just a picture in the background of them there, each with their own setup there, mapping, radios for dispatch and so on. They have two offices, one in Tala, near Tala Hospital, and one up in Ballyshannon. So, of course, the Ballyshannon one is the DR site, and either can handle all the calls to the country should one become available. So it's their job to determine if an ambulance needs to actually be sent, which it's not the case that an ambulance is sent in every call, but should they need to, they're the ones who are going to coordinate it, get the ambulance sent, and get the ambulance on scene. So once they dispatch the ambulance, it's normally the paramedics who are going to arrive there. They're going to assess the situation. So if it's a road traffic accident, they might call for extra help, like the fire brigade, to get someone out of the car. In most cases, a person can just be brought to hospital normally by road and it's not an issue. But in some cases, if there is a catastrophic injury, so for example, someone is having a stroke, myocardial infarction, which is a heart attack, or a catastrophic hemorrhage, well, this person needs to get to hospital quickly, which can often in the west of Ireland be a challenge because you've got mountain roads, a lot of places are inaccessible, the distance between hospitals is a lot greater than it would be in the Dublin region, for example. So each paramedic can call down the air ambulance if there is a number of conditions met. Ultimately, it's up to the dispatch to decide whether or not one is sent, but generally speaking, as I said, if it's a time-critical injury or condition, if the journey to an appropriate hospital by road is greater than 45 minutes, so I say appropriate hospital there because there's certain hospitals that have a speciality in certain things. So some hospitals would have, for example, a great stroke centre, other places would be better with heart conditions. You know, it's generally which hospital gives the greatest level of care for this particular injury. And in other cases, it might be, for example, there's no advanced paramedic available in that region. Not all ambulances carry advanced paramedics. The difference being that an advanced paramedic can give someone greater pain relief, they have greater expertise with the medicines that they can give you. So it's one of the factors that's involved in deciding whether or not an air ambulance should be dispatched. If one's needed, the call comes through to a special desk inside the National Operations Centre called the Air Desk. It's their responsibility for managing all air ambulance missions. Their job is to pass on whatever details, whatever assets are needed. It's their job to mobilise the helicopter, to get them ready. If the helicopter needs to land in a certain place, for example a GAA pitch or a golf course, they can call the guards to secure that area, make sure there's no one there, or if there's gates that are locked that need to be opened. And in certain cases, for example, University Galway Hospital there, they have the busiest helipad in Ireland. And it's often cases where, for example, Coast Guard helicopter be on the pad after delivering a patient, and they need to arrange for them to move so that the air corps will come in with another patient. At times, you know, it can be very busy, and it's basically their job to coordinate with all the different agencies involved in a rescue. So primarily the calls for an air ambulance are put through to Costoon Barracks in Athlone. The reason Athlone was chosen was from that central location, the Air Corps can reach pretty much anywhere in Ireland within 30 minutes. And they fly an Augusta Western 139 helicopter, which is a dual-engine aircraft. It's quite big. Anyone who lives in Athlone, I'm sure, would have heard it lots of times flying in and out of the place. So when a call comes through, there's 3 people involved. There's 2 pilots and 1 advanced paramedic on duty. The first pilot runs out to the yard and starts up the helicopter. The second pilot, it's his job to get the location of the patient from dispatch, work out where they can safely land the helicopter, what obstacles are nearby, and how best to approach. The advanced paramedic would then receive details of what's the patient's condition, is there anything you should know about it, past histories and that if they're available, and of course which hospital are they going to go to. That might change en route, but it's handy to have all this kind of planned out as they go. And more often than not, a helicopter's in the air within about 5 minutes. And if you think about it, the 3 of them, each with their own dedicated job, it's a lot of teamwork, and I've been out there for we went out for a day trip once just to see them in action, and they pretty much just run out the door. If that call comes, these guys are dead set on it. So this is a picture of them en route there. One thing you should notice there is, just to the side, is one of the printed data sheets that comes out of our system. On that there would be ESB lines, the location they're going to, and any potential obstacles they can face. So they use that as well as the onboard navigation system to find the best route there. So as I said, from Athlone to the west coast in about 30 minutes. When you're thinking about a patient who's suffering from a stroke, they have about 90 minutes to get to hospital. So you can see why this is such a valuable thing to have in Ireland. And as I mentioned there, the printed data sheet there has potential landing zones, obstacles that they could face, and so on. The ESB wire is actually the main obstacle. In the second week of them flying, the helicopter actually hit the power line as it came down. Luckily no one was injured, but they did manage to write off a couple of multi-million euro aircraft, so it wasn't a great start to the service as a whole, but I think they've kind of done well anyway. The helicopter itself is actually very flexible. You see it here landing on just a stretch of road. They can pretty much park this thing anywhere as long as they have a clear kind of path in, and the land is fairly level. So they've actually fitted snowshoes to it. It may sound a strange thing in a country that barely sees a centimetre of snow, but there was a case where it landed in a GA pitch once, and it caused dents in the pitch. And the manager of the club wasn't very happy with that, so they actually got snowshoes fitted to it so that it wouldn't actually damage any more of the pitches or golf courses that it landed on. They also use a feature called auto hover, where the helicopter rotor stays spinning when they land, so that the weight of the helicopter is held by the blades. So, for example, in bogland, where it would be very soft, if they turn off the helicopter, that'd be it, it would just sink. So it's an odd thing to have, but hey, it works for them, and whoever came up with it, fair play to you. You know, whatever works for you. One of the other things about it is, you see, they load the patient in from the side here, and on board the helicopter is a special kind of stretcher system called the life port. Because the helicopter, when it's flying, can bang to the left and right, not something you want when someone has internal injuries or really should not be moving. And of course, moving out of helicopter into an ambulance, you know, if they're hooked up to IVs or oxygen, it's, you know, you don't want to go disconnecting them, reconnecting them. So the life port system has everything built into it. It's about €1 million worth of kit, but even one life saved, I think it's worth it anyway. So this is a picture just of Galway University Hospital, and it's not just the Air Corps who do these missions, it's the Coast Guard as well. So the Air Corps do a lot of missions inland, whereas the Coast Guard are more suited towards the mountain rescues or anywhere out to sea. These guys are the ones who are called. So they're actually thinking of extending the helipad there, since two of them, as I said, is the busiest helipad in Ireland. Unfortunately, I think it's the only hospital in Ireland that actually has one. They're making plans to build on the Cork Hospital, and I think a few others as well, but mostly the Dublin hospitals would have a H painted in a car park, or they'd land at the nearest GA pitch to the hospital. So talking ambulance to helicopter to pitch to another ambulance and then to the hospital. It's not a great solution, but I suppose whatever you have, I suppose. So right, that pretty much covers the, shall we say, the human aspect of it. That's essentially what happens between calling and dispatch. So as you can kind of see, there's a lot of different things involved there, a lot of different people. And 6 years ago, when we were asked to help to design some software that could actually help these guys in their job, we came up with Health Atlas Ireland Aeromedical. The reason for such a verbose title is a lot of our projects were under a group called Health Atlas Ireland, and Aeromedical just was one module of it. So, yeah, I didn't pick the name. So, in a nutshell, it's a web-based system for managing air ambulance missions. It'll make more sense once we demo it. It's been operating 24/7 for the last 6 years. In terms of development, we're on version 5.10. So we've gone the first year or so. The first 2 years it would have been on Python-based software, Django and the like. Then once helicopter tracking came along, we kind of had to find a solution that worked. WebSockets seemed cool, but a complete and total pain to implement in Python at the time. So made the jump to Node, haven't looked back. So I'll go into some of the tech behind it now in a bit. The system itself was developed in collaboration with a number of different agencies. So HSE, obviously. Health Intelligence, which is a special division of HSE who use the best technology they can to help with patient outcomes. And you know, if there's any way they can improve them, they will. The National Ambulance Service, sorry, just to be clear, the logo's going right to that. The Air Corps, the Irish Coast Guard, the Ordnance Survey Ireland, who give us mapping data for a lot of different things that we use. Geodirectory, which is the address database system, and of course ourselves at Open App. So, demo time. Nothing go wrong. Now, I have to get this window from here to over there. This is going to be fun because it's not on my screen, it's on your screen. Never meant to be working at this resolution. So not far corner. Actually, let me see if I can just. Yeah, that's cheating, I know, but. Yeah. Right, so this screen is live across 50 different places in Ireland at any one time. This, the main map here is Ireland, obviously, and the blue circles you see are the actual locations of the Coast Guard helicopters right now. The red one in the centre is the Air Corps helicopter just parked in Athlone there. The reason they're grey in the moment is because none of them have moved in the last hour, but if they do move, they follow this blue track along. So you can see them there. So, it's really awkward. So, the box on this side is our search box. So we have address search, so we can search any of the 2.5 million addresses in Ireland. Handy when a patient says, yeah, I live at 123 whatever street. We also do air code searches. Can't actually stress, no matter what way you feel about air codes, they do uniquely identify brilliantly. So if you do have any relatives to that, or that you want to make sure in an emergency they need, you know, that the ambulance can get to the house, make sure the air code's near the phone. We've locality search, so there's some places in Ireland that are very rural that, you know, unless you live there, there's no way on earth you'd find them. About 68,000 of them in our database, so we have them there. Let me see. Of course it is. Live demos, everyone. Lost where my cursor is now.
There it is. Okay.
So, auto-complete search, not sure where that is. So there you go, and location of it there. So a lot of this is all about displaying the exact coordinates, which is something that's definitely needed for the helicopter that's flying there. We also have the ability to do a street view of the location. This certainly helps a lot more in rural areas where the helicopter might need to look around to see, well, there's the house, there's a field we can land in, you know, or if someone who is trying to talk to the patient, figuring out where they are, you know, I'd say, well, is it the house with the blue door or the red door from looking at the street view? I know it seems silly in that, but local knowledge, like these guys are in Tala, you could be in the west of Ireland somewhere, they're not going to know who you're talking about. You're saying so-and-so's house down the road, or, you know, trying the local landmarks or the rest of it. Let's see now. So we have the SMS bar here as well, which activates locating 112. There. What do I say? Hopefully no prank calls afterwards. So what that does, it should send a text message to my phone. Yeah. Asking me, please click the link to share your location. So I'll show you screenshots of this afterwards and that geolocation prompt. So on the phone it reads out the coordinates, but it also posts those coordinates back. So then I can simply just like this, and I'm somewhere within here. I know where, you know, it seems a bit strange, like, well, I know where I am here, but there has been cases where this has helped find people lost in the forest, lost on the side of a mountain, who really have no idea where they are, and it would take hours of searching to find them. Whereas this, just click, there you go.
Was that sent over by SMS? Or?
The text message is sent, yes, containing a link to click. Obviously you need a smartphone and one that has GPS for it to work.
Yeah.
And you need to have internet access.
Yes, I'll talk about all that after the Q&A, but yes, you do need internet access for it to work. There's only so many problems you can solve. Just, you say, this is our, we call this the target bar, so this target here, you can drag around to pinpoint a certain area. The readings across here, so we've got degrees, decimal minutes, which is the format used in aviation. Degrees, minutes, seconds, which you might be more familiar with on a GPS. ING is Irish National Grid, which is the grid system, the grid reference system for Ireland. ITM, or Irish Transverse Mercator, is the newest version of that, and just plain old decimal degrees. And it will shift through them on the fly, and any prompts that are showing coordinates, it will change them to match. Over here we have our map tools, so we can show the hospitals in an area, Garda stations, ambulance stations, and so on. I mentioned landing zones before. Each one of these red dots is a place that helicopter has landed. There's currently about 4,000 of them in our database. Each time they find somewhere, they say, yeah, this is a pretty good place to land. Make a note of it, it's stored, so next time there's an emergency, they can say, well, we landed there, it was fine, and we have the data sheet for that, let's go land there. So hard to do on on screen. Give me a moment. also have on the system here, and hopefully there's some there, we have power lines. The thin ones here are the medium and low voltage, so those would be the ones, for example, on the smaller poles. But big ones across here are high voltage, so those would be the ones in the really tall pylons, the ones about 100,000 volts or so. Definitely don't want to hit them with the helicopter. And I don't know if you can see them on here, but we also have the yellow dots, which are actual address points. So the geodirectory has each address in Ireland, but they also have records of buildings that are derelict, no longer used, so they make good reference points, or it's another obstacle to avoid. Finally, over here, we have just a very simple distance tool, essentially HB. Before we had this tool, the Air Corps had a giant map of Ireland on the wall and a piece of string. And they pin the string in one place where they're going to take off, pin it where they're going to land, take the string, and then go down to the scale at the bottom of the map. You imagine how accurate that was. So there's a few other bits and pieces in that, but I'll head back to the talk here and talk about the technical stuff behind it. Daffy.coding away there. So in terms of the tech here, look, it's nothing magical or amazing or cutting edge here. We're using Express, we're using Socket.io for the tracking, PG module because we have Postgres as our database of choice, LDAP because we use LDAP for authentication, we've got Mocha for testing, Winston for logging, handlebars for any of those pop-ups, templates, Phantom.js for data sheets because they're made in bulk. All 4,000 of them have to be printed off and signed by the Department of Defense to prove that they can actually land there. Imagine how time-consuming that must be. And of course we have the infamous PM2 just to make sure if anything falls over, it starts up again. Front end, OpenLayers 2, the other half is Socket.io. Proj4.js for handling the multiple projections that we use. jQuery UI because this was written pre-Bootstrap. Yeah, it's on the cards to rewrite it. Maybe we get Bootstrap 4, don't know, we'll see. Moment for just some of the timing stuff, and Google Maps just thrown in there because Street View needs all that stuff. The stack's quite simple. You've got, as I said, Postgres, Node, Express. Each one of these blue things would be its own kind of service running, its own instance of Express, so it kind of separated them all out. So basically if one fails, it's not going to take down the whole stack. So login and front end, so login serving static files is one, map features and search is another instance, data sheets, tracking, SMS, they're all their own systems, each independent, so we can upgrade one, restart another, so on. PM2 and then Nginx and SSL for, we use SSL certificates, so unless you have the cert installed, you're not going to get to the site, just extra bit of security. And that's pretty much it. I mean, it's not magic, it's stuff you're all familiar with, but I think we're using it for an interesting project here. So just on the web mapping and GIS side of things, it's all lines, points, and polygons. So you've got your, there's over 1,000 service features in there between the hospitals, the guard stations, and so on. So that's all points. 4,000 heli sites, as I said. We have also 30,000 different motorway markers, emergency roadside telephones, Irish rail markers, bridges, anything that has some sort of ID that in an emergency someone could say, well, I see a sign and it says this, can you tell me where I am? I don't know if any of you are really familiar with that with the motorway going out towards Athlone and that, there's two stations there, apple greens, and they look completely identical. So there's cases where, for example, locating 112 has been used to say which one person was in, or if they can say, look, the marker posts say N versus W, north versus west. There's cases where that stuff helps. So we've 68,000 gazetteer points, so strange, obscure rural areas that no one would ever know unless, if you're looking for Craggy Island, stuff like that. About 75,000 high voltage power lines, so the ones on the tall pylons and that. Close to 1 million small, like medium and low voltage lines. After a storm, it's really fun seeing these numbers change. The amount of them they have to replace is ridiculous. And about 2 million address points. So each one comes from a different agency, a different source. So it's a bit of work keeping each up to date, but that's what they pay us for. We use Postgres as our database of choice. The main reason is because the Post.js extension, so we can actually store points, lines, and polygons in the database and do work with them. So distance from this, does this intersect, stuff like that. And of course, the fabulous Node Postgres module. I think it's one of the most used modules in OpenApp at the moment. So to kind of go from Postgres to the screen, we built Node.js feature server. So it's inspired by the Python project of the same name. It provides a RESTful geographic feature service. Essentially that just means I want all my hospitals, here's the call, it goes to the database, brings them back up, and serves as GeoJSON. So it's just to open there so we can consume that. It also provides different search interfaces for certain layers and that. It's kind of been the basis for a number of different projects in OpenApp as well. Just going from database to map. Open layers in the front. We looked at other mapping libraries like Leaflet and so on, but because of the amount of data we see in Irish projections, Irish National Grid and so on, Open Layers can handle that a lot better for us. The Ordnance Survey, their stuff comes in 2157, so the Irish Transverse Mercator projection. But just trying to get Leaflet to understand that was just a world of pain. As I said before, the Proj4.js library, we use that a lot when we go from any weird obscure projection to another. And for the larger data sets like the ESP power lines, that's a lot of data, so we just use bounding boxes just to make sure that we just want this section, and that's all we load, rather than have the browser crash. So speaking of the power lines themselves, we get every 6 weeks the data for the entire ESB power grid. Now when I say all the data, I mean all the data. Everything from the ducts, the labels that they put on it, it's CAD level data. So we get it under a special license. HSC is a special agreement just for using it just for this. The update comes every 6 weeks and it comes on a DVD. I think maybe 6 other people in the country get this disc sent to them. It's really rare and really hard to get out of them. It took like 6 months of negotiations or 8 months and a lot of legal NDAs and all the rest of it going back and forth. So for processing we use a library called GDAL. It's like the Swiss Army knife of weird projection formats, and from that it just takes in the CAD data, spits it into the database, and from there we can use a lot of SQL and remove all the unwanted features. Because essentially we get everything, all the stuff in the ground, all the overhead wires. Helicopter's not going to crash into the wires in the ground, so we need to kind of strip all that stuff out. And the only way we can kind of, let me just give you a hand here, Sean. The only way we can actually verify we spend an afternoon with this, checking that this matches the maps that we produced. So on this, it's the printout of the Tagadoo substation just outside Maynooth. On it are high voltage lines, both underground and overhead. And essentially we make sure that on the map, there's only red lines and there's no blue lines. It would be great if there was an automated way to do this, but you have to make sure that what the ESB says is there is actually on your map. And it took months of working in QGIS and, well, what if we delete this layer? Because the stuff that comes out of the CAD format in the database, it's all sorts of weird attributes and level numbers and color numbers, and essentially you have to tweak it until it looked like this, and it could say, yeah, that's close enough. Nothing's crashed into a power line since, so I think we're doing it all right. So just visually there, this is that 75,000 high voltage power lines laid on the map there. So you can see some of the corridors that go along, some across the top there into the Midlands and heading up into Donegal. So it's quite a network there. And then the medium and low voltage. There's a lot of them there. You can kind of see gaps where kind of the Wicklow Mountains and that had nothing there. And as you go up to Donegal, kind of the mountains, kind of the peaks kind of show through. But it's mostly just, they're everywhere. And you can see why flying a helicopter, that's a big danger. So the only thing it doesn't show in the data is actually the individual connections to houses, kind of the last mile, but pretty much that's everything there. Right, so we'll just talk about the aircraft tracking that we have. I wish it was as elaborate as that. Right, so the Irish Air Corps, they have 2 helicopters and only one's kind of flying at a time. The other one's just a backup, normally held in Baldonnel. They have a company called Track 24 based in Canada who provide them with this device that they essentially stick to the windscreen of the helicopter that they're going to be flying that day. And inside this device has a GPS and a satellite radio. So the device basically every so often picks up the GPS location and sends it back over the satellite network. So it's the Iridium satellite network, very slow, very expensive. So the update resolution it's kind of low, but it's good enough to see them on the map and track them. I think it's like once a minute, but there's a certain time slot that it can send. And if the helicopter's banking while it's doing that, you might miss the satellite, or a number of reasons why it doesn't work. We're hoping to do better. Track 24 receives the messages the other side and literally just posts them to the server. There's great crack implementing that because initially we thought they'd post the updates in order. They didn't, so the end of the helicopter went backwards and forwards. Pay attention to the spec, the timestamp there was critical. The Irish Coast Guard then is a different story. They're tracked by the Department of Defence, Transport even. Their locations are captured by the AIS network. That's the Automated Identification System, which it's normally used for ships to avoid colliding into each other. But the search and rescue helicopters they have, because they go out to sea, they're classed as vessels. So they have this tracking system on them as well. And the Department of Transport have a centralized server where it's all collected. They filter it, just give us a few helicopters. We connect to them through TCP and we get back AIS messages, which which meant we had to build a decoder to actually read them. So that's the message we get. If anyone straight off can go from that to that long, fair play to you. It took a lot of research and 100 odd pages of technical specifications to read it, but essentially it's a 6-bit ASCII encoding representing a binary message. So each one of those characters is worth a certain number of ones and zeros. So, for example, the actual message begins at the 9 here. The rest of it's just checksums and that. So character 9 is ASCII value 57, but we're talking 6-bit ASCII, which has a range of 0 to 64. So we subtract 48, we get 9, which bit shifted gives us this. Or after you change it, you end up with this. Yep, very intuitive. So buffers were the first thing we said, sure, we have binary Node, great, we'll use that. No, they only deal apparently with bytes. It wasn't the bit level, and we were talking 6 bits, not 8 bits. It didn't work. So parse int was the thing that saved the day here. Value and rate x here being your base. So base 10 normally, but base 2 saved the day here. So in AIS, different offsets and bit lengths give you the different attributes. So altitude begins at bit 38, and that's 12 bits in length. So that gives you an unsigned integer. So parse int of that from the previous slide, base 2, 69 meters. So we get these messages streamed about once every 10 seconds, and our decoder goes through this, and we store them all then in Postgres database, whether it comes from Track24 or whether it comes from the Coast Guard. And then in the front end, it's all connected via WebSockets. So as soon as there's an insert done on the database, a new tracking event is triggered, all the screens update in unison. So that's, we only keep the last 24 hours of tracking data. There is a lot of it, and legally we're only allowed to do that. So basically at 12 o'clock every night we kind of keep the last locations but wipe the rest of it. Of course, in the case of Rescue 116 and the rest of that happened, we did have to play a part in that where we gave them whatever data we had. So there are occasions where we can break that rule, but more often than not it is just deleted afterwards. I'm going to type in the time here, I think. So. No, you're good? Okay. So just a few things on the KP112. I picked the forest background here for a reason. There's just a little bit of a story there. We released it August 2014, and the day after we released it, we went to the Coast Guard headquarters. We were going to give them a talk through how the thing worked and when to use it and that. And after we'd actually given them the demo, they said, yeah, we had to use it actually last night. Apparently, they got a call around 9:30 at night from a father who said himself, his wife and his 3 kids were walking around Cratloe Woods in County Clare. And they got lost, got turned around, they didn't know which way to go. It was getting late, very dark. And that area is about 700 hectares of forest. So you had to search for them. That's going to be a long night. They used the Locate Me 112 system, found them within about 10 or 20 meters, and they had the helicopter out there in no time. So I think they were at home in bed by about 11:30 at night. So it was kind of great. After giving the demo, hearing, well actually, yeah, we've used it. So good outcome anyway. Right, so just the reason behind the Locate Me system. Air ambulance missions, unlike the road missions, they need a location to fly to. You can't take off unless you know where you're going to land. So that's just a strict rule in aviation, you can't do it. road ambulance, you might say, yeah, well, we got to call in NACE. Okay, it's this estate in NACE. Okay, it's this house number. Okay, dispatch them and kind of guide them on the way. You can't do that with an air ambulance. It goes from here to here, and that's it. The emergency call answering service can pinpoint the location of a landline because a landline is registered at a physical house, which was great for a while, but in the last 5 years, over 2/3 of the calls are coming in via mobile phones. So Ireland does not implement the radio resource location services protocol. That's used in America where they can turn on the GPS chip in the phone and get the location of the phone without the owner having to do anything. We don't actually have that protocol or technology here. So unless they actually tell you where they are, you won't know where they are. The closest cell tower is about the best you can do. If it's in a rural area, you're talking this a 20-kilometer zone. In an urban area, you might get down to maybe a kilometer or a kilometer and a half or so, but it's very hard to pinpoint someone who's on the phone. So locating number 2, we figured most people have smartphones. Smartphones have GPS, the geolocation library there. Very simple to just send something to activate that. In the case of locating number 2, we send just a unique link, a short link via SMS. We just click that, it opens the default browser, triggers the geolocation, and then we just get that posted back to the server. You do need a data connection for it to work. That is one of the problems with it. If you're on the side of a mountain, okay, your network coverage is probably not going to be great. That's why we took a lot of care to kind of engineer the hell out of the thing that we send them. So it's actually about 5 kilobytes in size. So there's a little animation on it, even that is base 64, your data URI encoded. So there's only one connection and one connection back to the server. So we tried to minimize the going back and forth just to make sure this was the tiniest package we could possibly send. Originally it didn't have the animation that flashed, but people thought it did nothing. Kind of like the ASCII loaders, where it's like the Ajax loading kind of spinning animation. It's waiting, but people are more patient when they see it, so that's where we put it there. And of course, all this was developed in collaboration with the Air Corps. Colin Gallagher, I think it was, over there, kind of came to us with a mock-up of it and said, well, is this something we could use? And we just ran with the idea because it seemed brilliant. This is essentially the screens you see. Text message comes in, they click the link, the standard geolocation prompt, and there we are. Now, like I said, it's very straightforward here. The reason we show the coordinates on screen is if they don't make it back to the server, the person can just read them out. So, you know, we just need at least one request to succeed, and that's it. It's just some quick stats. Over 4,000 text messages sent using the system. 3,600 delivered successfully, because sometimes the numbers they put in are wrong, off by a digit, it's a foreign phone, you know, a number of reasons. Over 1,500 people successfully found by this system since it was put in operation. The devices, about 45% Android, 52% iOS, 3% other Windows kind of phones and things that just didn't work. And the average location accuracy is about 200 meters. So if you think a helicopter needs about that to land, get an hour in someone's location down to that in an emergency is pretty good. So in terms of future developments, we would like to improve the Air Corps tracking and that. At the moment, the two systems that we have, they kind of work, they have their quirks, but we would like to move to ADBS, I think it is, the standard kind of radar tracking the aircraft have. You know, if you go to Flight Radar or those kind of websites, the way they track those planes, we'd like to kind of move to that kind of technology. There's a lot of things in the front end that we'd like to improve, but overall it's evolved kind of organically. It works. We're happy with it. They're happy with it, and day and night is working. So pretty much that's it.
Any questions?
Yeah, so man, very really interesting talk. My question is, did you have any insight on what other countries used, or like what the state of the art was, or was it just this is what we need to do and kind of evolved from that?
Well, most of the countries don't actually have government-funded air ambulance service. For the likes of England and that, it's all community-funded. They do various charity functions to raise enough money to actually fly the helicopters. The state of the art is, well, we did some research, there's not much out there. I mean, there's off-the-shelf commercial systems you can buy, but none of them were kind of customized, shall we say, or they didn't fit the need that we had. And the fact that the ambulance service and that could say, well, could you do this, or could you do that? The fact we're using open source software and built this kind of from the ground up meant that we could give them a system they need that they actually could use. So I think Germany has a better kind of setup in terms of the air ambulance. I think they do have government funding there. In terms of the systems they're using, I'm not sure. I think it's commercial systems as well, but the real focus was something that could change and customize and to suit them. So I hope that answers the question. Cheers.
Hey, you said you use the GDAL geolocation, right? So how is this geolocation separated with the real world, and how is the difference between the GDAL and the GPS geolocation?
So the difference between GDAL...
Between the location that you point on GDAL and on GPS, how's the difference about the meters? You can have like a range, the difference range, because I asked you this because I worked this before using the UTM geolocation, and the difference could be from 100 meters to 2 kilometers between the points, and if you try to use this and point it out in a map.
Yeah, well, we take whatever location the phone gives us back, and there are cases where some phones have a better GPS than others. In the geolocation spec, it says there must be an accuracy rating. We have seen cases where the location we get back, the accuracy is 2 kilometers, or I think the biggest we saw was 6 kilometers. You know, so there are cases where it's just, well, thanks, it told me it was somewhere in this big region. That's not very useful. The iPhones provided, you know, they recently used Google Maps or something like that. The GPS is hot, you can get down to about 60 meters or about 10 meters, but it is a problem in some cases. We do try and poll to say, well, you know, try a few times, can you give us the better location, but we just take whatever we can get.
Any other questions? What's your QA and release process like, considering it's such critical software?
Not as well defined as you hope. No, seriously, there is a lot of guys in health intelligence who spend a long time kind of reviewing each release. They will put it through their paces and that. We have in-house testing as well. We've certain test case that has to go through. As I mentioned in the slides, we Mocha there as well. We've a full set of tests to run. Some things could be better. Obviously, the paper maps and verifying things that way is a bit risky, but I suppose, you know, better than nothing. The releases are kind of slow. We're shipping every week, but once a release does go out, it's been thoroughly tested and a lot of hands have looked at it.
Thanks. Anyone else?
So let's say that your locate me doesn't work, so like I'm in the middle of nowhere and you can't get a signal. What's the process then of using like cell towers to find me? Does that front end like let you do that, or do you have to ring someone up and, you know, would they do it?
Well, the dispatcher would have access to the ECAS system, which will show which tower the phone was using. Like I said, if it's in a rural area, there could be, the cell itself could be about 20 kilometers in size, so it didn't really help in that matter. It doesn't do triangulation or trilateration of the different cell towers. It just literally tells you it's cell tower 1, 2, 3, 4, you know, and it happens to be here. I'm afraid it's not as advanced as you see in the CSI or those kind of things.
Alright, thanks.
Thanks for the presentation. I'm wondering, how can you ensure the availability of the application, the platform, for 24/7? I mean, apart from PMQ, do you know? If you can elaborate a little bit.
Good question. We have our completely redundant setup ready to go. We have servers in Blanchardstown and Park West, so the whole thing's based out of Ireland. We own our own servers in that for it. We have 24-hour coverage with our SLA for calls and that, so if 3 o'clock at night, I'm unfortunately the one who gets woke out of their bed to fix it, or
yes,
whatever
you
else
are.
The thing that's been rock solid so far, that these guys do have paper backups of everything. So all the heli sites that they can go to is printed out in a book and a binder about that thick. They prepare for situations like that. They know that the system may one day just not load, and they have complete paper backups for all of this. It's no substitute for what is on screen, but it's something at least.
Any more questions? Perfect. Thanks a million, Nigel. We're going to have a 15-minute break and then we'll have a